In the past, we would use something along the line of this to model a golf game. So we would use something along the line of this to model a golf game. So if you're standing let's say 100 meters away from your target, then we would slowly need to morph this into our scenario. So if you're standing 100 meters away from the target, you would probably need to stick some sort of constant in here and maybe change the constant in here. But the point is that you would slowly morph this to suit our scenario. So if you want to know the probability of you hitting the golf ball and landing within a certain region, then we need to consider. Well, don't forget, if you get a graph plotter and plot this, you would get something that would look like this red line here. Well, the height represents in a way represents a frequency at which you will land within this region here. So if you're aiming at a certain target, you're more likely to land around your target than you are far away from your target. The point is that we would need to if we want to know the probability of us hitting within a certain region, we would need to combine the area with the height. Well, combining the area with the height is really us revolving this thing 360 along the y-axis. So if we want to work out the probability of it landing within a certain area, we would need to consider the 3D revolution of this thing, the 3D object. So we would need to look at the 3D solid, this 3D solid here. So remember, hang on. So if you get a graph plotter and plot this, you would get something along the line of this. But then to work out the probability of it landing within a certain region, you would need to combine the area and the height. Well, combining the area and the height is really us looking at the 3D object here, this 3D object here. So the point I'm trying to make here is that the volume has some sort of meaning, it has some sort of significance. Now so in this scenario here, the volume, the 3D revolution, when you revolve this 360 along the y-axis, the 3D object, this 3D object here, has some sort of meaning associated with it. Now we are going to look at, well, looking at this model now, looking at the same model, our next aim is to work out the flat area, not the 3D version, but just the flat 2D area here, because up here the solid here has some sort of significance, it has some sort of meaning associated with it. Well, the flat area also has some sort of meaning associated with it, and it will serve us well as well. The area alone has some sort of significance. So, for example, if you look at the population of the height of people, if you look at the population of the height of people, you're going to get a lot of people at the average height. Once in a while you will get a really tall person, once in a while you get a short person, but by and large you're going to get a lot of people of average height. So if you get a graph plotter and plot this, you will get this graph here. Okay, but the point is that if you let this to represent your average height, you're going to get a lot of people clustered around the average height. Once in a while you will get a tall person, once in a while you get a short person, but here in this scenario here, a 3D object has no meaning. A 2D area has a lot of meaning in this scenario here. So our next aim here is to work out the area of this thing here. And working out the area of this is not easy. You see, working out the volume of this is easy because, hang on, working out the volume of this, when you revolve this 360, when you revolve this 360 along the y-axis, it's easy to work out it's easier to work out the 3D solid here than it is to work out the area of this thing here. Well, I will carry on in the next video, but working out the area of this is a lot harder than working out the solid here, and I will explain why in the next video.